So good day everyone. Again, this is Engineer Freedom Karodan, and for today's video, we are going to study a general formulation of the force or the flexibility method called the consistent deformation method or the force method for the analysis of, again, statically indeterminate beams. Okay? So consistent deformation method or the force method is a method which was introduced by James C. Maxwell. It was introduced in 1864. Okay, so it essentially involves removing enough restraints from the indeterminate structures to render it statically determinate. So this determinate structure, which must be statically stable, is referred to as the primary structure. So the excess restraints removed from the given indeterminate structures to convert it into determinate primary structures are called our redundant restraints. Okay, and the reactions or internal forces associated with these restraints are termed redundants. Okay, so the redundants yan. So since the independent variables are unknowns in the method of consistent deformation or CDM are redundant forces and or moments which must be determined before the other response characteristics or examples the displacement that can be evaluated. The method is classified as a force method. Okay. So first is we have the procedures for analysis of using method of consistent deformation or the force method in the analysis of statically indeterminate beams. Okay, so first is we have to determine the degree of indeterminacy of the structure. So we have discussed how to determine determine the determinacy and stability of a beam. Okay, we have to compare our uh, unknown reactive forces against our number of equilibrium equations. Okay, so yun yung una. Okay, and then select the redundant forces and or moments. So the total number of redundants must be equal to the degree of indeterminacy of the structure. And also, the redundants must be chosen so that the removal of the corresponding restraints from the given indeterminate structures results in a spunding restraints from the given indeterminate structure results in a primary structure that is statically determinate and stable. Okay, the senses of these redundants are not known and can be arbitrarily assumed. A positive answer for a redundant will apply that the sense initially assumed for the redundant was correct. Okay, and then for the step 3, remove the restraints corresponding to the redundants from the given indeterminate structures to obtain primary structure. So yung gagawin muna natin is to determine and then select this. So if we have two redundant or we have second degree of indeterminacy, therefore we have to remove two restraints from our structure. Okay, so yun yung number 3, remove the restraints corresponding to the redundance. So yung redundance is based on our degree of indeterminacy. Okay, so ayan, and then for number 4, draw a diagram of the primary structure with only the external loading applied to it. The unit force or moments must be applied in the positive direction of the redundant. So next is we have to draw a diagram or sketch a deflected shape of the structure. So yung structure na yun is our primary structure. Yun yung structure natin na determinate or without this corresponding redundance. Okay? So we sketch a deflected shape of the structure and show the deflection or slope at the point of application and in the direction of each redundant by an appropriate symbol. Okay? And then another is to draw a diagram also for each redundant. Okay? So, draw a diagram of the primary structure. Okay? So, yung primary structure or yung original structure with only the unit value of that redundant applied to it. So the unit force or moment must be applied in the positive direction of the redundant. And then also, as you have processed our primary structure, ganun din ang gagawin natin for our redundant structures or our virtual structures. Okay, so sketch a deflected shape of that structure and show by appropriate symbols to the flexibility coefficients at the locations of all redundants. Okay, so to indicate that the load as well as the structure response to is to be multiplied by the redundant under consideration, show that the redundant preceded by a multiplication sign. So ayan. So the deflection or slope at the location of any redundant due to the redundant under consideration is equal to the flexibility coefficient at that location multiplied by the unknown magnitude of the redundant. Okay? So kung medyo mahirap i-process, mas madali mamaya for our examples. Okay? And then for next, the step 5, write a compatibility equation for the location of each redundant. Okay? So madali lang naman siguro yan. We have to analyze ano bang meron sa beam na to. Okay? Ano bang meron na mas mapapadali yung ating analyzation? Ano ba ang relationship na pwede nating mabuo? So yun yung tinatawag na compatibility equation. Okay? So the total number of this compatibility equation must be equal to the number of redundants. Okay? So kung meron tayong 3 redundant supports or reactions, there must be a total number of 3 compatibility equations. Okay? So for step 6, compute the deflections and flexibility coefficients involved in the compatibility equations. So a deflection or flexibility coefficient at the location of the redundant is considered to be positive if it has the same sense as that assumed for the redundant. So kung yung final answer natin is positive, therefore yung assumed natin na direction of the assumed direction or rotation of our assumed rotation or direction, therefore tama yung assumption natin. Okay? So kung positive yon, therefore tama yung assumption natin. But if naging negative, therefore we have to correct the direction and the rotation of our assumed forces. Okay? And then so number 7, substitute the values of deflection computed in step 6 into the compatibility equations and solve them for the unknown redundants. So basic na lang siguro yan. And then after these redundants have been determined, the response characteristics or the reactions, shear and bending moment diagrams or member forces of the indeterminate structures can also be evaluated either through equilibrium considerations or by superpositions of the responses of the primary structure due to the external loading and due to the each of these redundants. So okay, kung medyo mahirap i-process, therefore we have to make or to solve for a example to understand our topic better. Okay? So ayan. So this will be our example number 1. Okay? So example number 1, consider the continuous beam loaded as shown. So our flexural rigidity is constant. So ang tanong is determine the support reactions in this given beam. Okay? So let me flash my prepared solution for this problem. And so consistent deformation method or the force method. So simple lang naman yung concept niya, okay? So ito yung let's take this example, okay? So we have this continuous beam. It has a uniformly distributed load that is applied to it, okay? So we have this assume deflected shape. So ayan, we have this deflection, okay? And then yung concept nitong consistent deformation method is we first determine the determinacy of this beam. So meron tayong formula dyan which is R so R depending, which is compared to the number of equilibrium equations and the number of parts. So we have 1, 2, 3, and 4. So we have 4 unknown reactive forces, and then we have only one part. Therefore, the indeterminacy of this beam is at the first degree. Okay? So therefore, yung concept niya is we have to remove one redundant reaction from our beam. Okay? So to achieve or to get the primary structure. So ito yung so we have to remove this redundant reaction here or redundant support. So kapag ni-remove natin yan, therefore, yung deflected shape nito is mag-iiba. So magiging ganito siya. Okay? So the number of remove redundant reactions is equal to the indeterminacy of this beam. So meron tayong 1 degree, therefore magtatanggal lang tayo ng 1 redundant reaction. Okay? So yan. So yung ito yung tinatawag na primary structure. Okay? Yung meron na tayong determinate structure. Okay? So this is a determinate structure. This is a simply supported beam. Okay? So yung assumed deflection niya is this. Okay? And then yung concept niya is, what if this support reaction here, By, and then remove all the original loadings or the real loads, and then we apply a 1 unit load at that at that redundant reaction. Therefore, we can assume we can compute for assume this is the assumed deflection of our redundant applied unit load here. Okay? So ito yung magiging deflection nito without these real loadings. Okay? So ang concept niya is that when we add our primary structure to the unit load virtual load, is that we can achieve this same structure or the original structure. So ang gusto niyang ipaalam is that when we add the deflection at deflection of this primary structure and this deflection upward deflection of this 1 unit load By, is that we can achieve this original form. Therefore, mapapadali yung ating computation since we are dealing with statically determinate na. Okay, so we have this statically determinate, compute natin yung deflection niya, and statically determinate, and i-compute din natin yung kanyang deflection. Okay, so kapag pinag-add nyo kasi this is downward, therefore and then this we have upwards, therefore yung upwards na yan, so ma-minus natin yung downwards, minus natin yung upward na deflection due to this load. So magiging ganito lang siya. Okay, so yun lang yung concept niya. Okay, so let's proceed to the real problem. Okay, burahin ko lang to. Okay. So this was our problem. Determine the support reaction of the beam shown. So first is we have to determine the determinacy of this beam. Okay. Since we have 1, 2, 3, 4, 5. So we have 5 unknown reactive forces, and then we have one part only. Okay. So therefore, our this beam is indeterminate to the first mali pag hindi mo marunong mag-minus. So indeterminate to the second degree. Therefore, we have to remove 2 redundant reactions from our sample. Okay? So ano yan? So this from the original structure, this is the qualitative deflective shape of our beam. So yan yung assumed deflection of our beam. Okay, we have deflection, zero deflection at these supports. Okay, so first ang next na gagawin natin is select the redundant forces and or moments. Okay, so alam naman natin na ito na yan. Okay, so we have to remove these 2 redundant reactions from our structure. Okay, so removing the restraints corresponding to redundance from this given indeterminate beam, we can obtain our what we call the primary or our determinate beam. Okay? So ito yung ating magiging primary or the determinate beam. So nagiging simply supported na siya. Therefore, we have statically determinate structure. Okay? And then we have to next is we have to compute therefore our reactions at both A and B. And then syempre we have to uh, analyze our structure since kailangan natin gumawa ng deflected shape of this primary structure. So yun, ito yung assumed qualitative deflected shape of our structure. We have the deflection at B and then also our deflection at C since we remove this corresponding redundance from our original structure. Okay? And then computing for the reactions at A and D, madali lang naman na yan. We can use the equilibrium equations to solve for these reactions from our determinate structure. Okay, so solving we computed for reaction at A and D. Since this is symmetrical, therefore the reactions at A and D is just equal to 90 kilonewtons. Okay, and then ang next is to ito na yung diagram. And then for next is for each redundant, we apply a unit value to each redundant. So first is we have for this reaction at B. Okay, so this is only assumed this is only a assumed direction or reaction of our support. So nag-assume ako na the reaction at B is downward. So magsa-self-checking naman na yan after siguro when we compute for the reaction. So kung negative, therefore we have to change the direction or the direction of our assumed force. Okay? So ito muna is we have a unit load applied to our considering the redundant reaction, redundant support from the point B. So RB. So we have a one unit load. So tatanggalin natin yung real loads. Therefore, we apply a unit load on the beam itself. So we can compute for the deflected shape of this corresponding redundant. So kapag knowing nyo yung deflected shape niyan, we can assume that this is the deflected shape of our beam. Okay? So we have this kung nakikita nyo dyan, we have this coefficient siguro. We have this delta BB. So kung babasahin nyo yan, it is the deflection at B caused by this 1 unit load at B. So delta BB. So 1, so deflection at B. So ito yung point B. Okay? So ito yung point B. Wait lang, arrow. So ito yung point B. Okay? Ito yung point B. So deflection at B due to the load applied to point B. Okay? And then for, of course, meron din tayong deflection at point C. Since wala na siyang support at point C. Okay? So meron tayong deflection at C. So meron tayong deflection at C due to the applied load at B. So delta CB. And then after that, you can solve for the corresponding reactions from our determinate supports. Okay? And then next, since we have two redundant reactions, therefore we have to create two virtual systems for our problem. Okay, so this is the main system or the primary structure, and then we have two virtual systems due to the two redundant supports. Okay, so next is we apply a load at point C. Okay, so therefore meron din tayong deflection at C. So this is the deflection at C due to the applied load at C. And then meron din tayong deflection at B since we do not have or remove the support corresponding at point B. So therefore we have a deflection at B due to the load at C. And then again you can compute for the reactions at both supports. Okay. And then for the next step, So step 5 na to is we write a compatibility equation for the location of each redundant by setting the algebraic sum of the deflections or slopes of the primary structure due to the external loading, and of course each of the redundants equal to known displacement or rotation at that corresponding location on the actual indeterminate structure. So ang ibig sabihin lang nun is we have to sum up. If we sum up this deflection, so this deflection at B, deflection at BB, so ito yung tinatawag na flexibility coefficient. So yung flexibility coefficients na yan, o delta BB, yan, we have to multiply it to the reaction at B. Okay, so since this is a coefficient only, we have to multiply it to the real reaction at B, so RB. And then, of course, ganun din sa okay, so both coefficients must be multiplied to the reactions considering the virtual system at that point. Okay, and so we have to write the compatibility equations. So we have to at that point when we check for the sum of these deflections, so delta B, delta BB, and delta BC must be equal to the deflection on the actual indeterminate structure. So this deflection plus this deflection must be equal to the deflection of the actual indeterminate structure. Since this in the actual indeterminate structure, so makikita nyo naman dyan, our deflection is equal to 0. So we can create that compatibility equation that the deflection at B, ito, primary structure, plus the coefficient BB times the reaction at B plus delta BC or CB, mali. So delta BC times RC is equal to 0. Must be equal to 0. Okay? And then next naman, ito, sa point C, is that the deflection of C plus the deflection at C due to the point load at B times RB plus deflection at C due to the point load at C times RC must be also equal to 0 since sa actual natin na indeterminate structure, our deflection at point C is equal to 0. Okay? So, and then so yun lang yung pwede nating ma-assume. Okay? And then pwede nating i-check na rin that kung makikita nyo naman dyan, that the deflection at BC or the flexibility coefficient at B due to that load at C is just equal to equal lang silang dalawa. Okay? Kung mapapansin nyo naman. Tama? Okay? 4 over 13. So, 1 kN load, 1 kN load. Same lang yan. Okay? So, next part is we have to compute the deflections and the flexibility coefficients involved in the compatibility equations by using the methods discussed in prelims and midterms. So we can use the virtual work method. Okay, pwede virtual work method, moment area method, pwede. Okay, so we have to compute this yung mga ating unknown compatibility equations. Ito yung tumatawag. So delta B plus delta BB delta BB delta BC. Okay, so 1 2 3 4. So delta BC same lang din naman yan. So we have to find out 1 2 3 4 1 2 3 4 5. So 5 unknowns. Okay, so we have to solve those 5 unknowns. So ang gagamitin natin dito is for since we have the virtual system naman na dito, okay? So we have to solve this using the virtual work method. Okay? So kung hindi nyo alam yung virtual work method, so you have to research for that method. Okay? So yung meron tayong table na ginagawa for virtual work method consisting the segment, the limit, the primary structure moment, the moment due to that virtual system, and the moment since we have two redundant virtual systems is we have two moment of virtual systems. Okay, so we have the segment AB. So So, yung segment AB, nakalagay naman na dyan yung point of cutting plane. Okay? So, for this segment AB, we have this cut x1. Okay? So, from 0 to 4 siya. So, yung limit niya is from 0 to 4, AB. Okay? From A to B, that is 0 to 4. And then, when we solve for this, so, ito pa lang yung main, ito yung primary structure. Moment at the primary structure. Ito. Okay? So, when we solve for this moment at this primary structure, we can compute this moment at that segment. Okay? So, 90x minus 5 over 6 times x cubed. Okay? And then, so marunong naman na siguro kayo dyan to create a moment equation in a determinate structure. Okay? And then, for BC naman, we have this cut x2. Excuse me. Okay? So, BC is from 4 to 9 na siya. So, 4, start niya, and then 9. Okay? So, from 4 to 9, ito yung magiging moment equation natin for that segment. Okay? And then, for segment CD naman, so, pwede lang man kayong, nasa inyo naman yan. So, pwede nyo i-cut dito from the left side. So, ang pinaka-convenient kasi is from the right side na lang. So, onti na lang yung makasakop niyan. So, from the right side, so therefore, yung limit niya is from 0 to 4, CD. Okay, so from 0 to 4, we can compute for this moment equation. Okay? And next is we have to compute the moment equations due to this virtual system then. Okay? So, ganun din yung cut niya. Okay? So, cut ka dito, and then solve for that moment equation at that segment. So, ganun pa rin yung limit niya. And then, ganun pa rin for BC. So, solve nyo lang yung mga moment equations for this virtual system at B. So, MB. So, maliit na M siya. So, for the primary structure, malaking M. And then, for the moment at C, ito naman siya. Okay? So, solving for the moment at C, virtual system at C, ito yan. So, ganun yun yung cut niya. When mag-cut tayo dito, okay? So, yung moment equation na mangyayari or can be computed as 4 over 13x. Okay? So, sa next naman, so since ito lang naman, same lang naman yan. Andito pa lang yung 1 kN. So, same lang yung magiging moment equation natin for AB and BC. Ang may iba lang is our limit. Okay? And then, same din sa CD, ganun din yung cut. Okay? So, magiging 9 over 13x siya. Ito. So, yun yung ating magiging moment equation for the virtual system at C. Okay? And then, to compute for the deflection at B, alam naman natin, ang deflection or from the virtual work system is that we integrate the primary structure moment times the virtual moment and that at that point. Okay, so malaking M times MB. So, when we integrate, so integrate natin, kunwari, number 1, ito, number 1, segment AB. So, ito yan, from 0 to 4, and then, yung M na malaki, 90x minus 5 over 6x cubed, times our moment at that virtual system. So, 9 over 13x dx. So, we can achieve this answer. Okay? And then, ganun din gagawin nyo sa ibang mga moment. Okay? So, for delta C, ganun rin, but the primary structure moment is then multiplied for the moment equation due to that virtual system at C. So, ganito rin yung makukuha nating mga sagot. Okay? And then, for the flexibility coefficients, so, for the deflection at B to the point at B, therefore, kailangan lang natin i-integrate yung ating moment at B and then squared lang. Okay? So, moment at B to that moment at the virtual system at B squared. Okay? So, then, ganun lang. Drawing na lang. So, from 0 to 4, MB squared. So, M, ito, 9 over 13x squared dx. So, we can compute for this problem. For these answers. Okay? And ganun rin sa, since BB yan, so therefore, squared. B. So, BC naman, kapag BC, yung moment at virtual B, and then moment at the virtual system at C. Okay, ganun lang din. Very easy lang. Okay, and din sa deflection at C due to the point load at C. And then of course, to solve for this deflection at B, kailangan nyo lang isum. And then deflection at C, summation. Deflection at BB, summation. Okay, so ilan ulit yung hanap natin na compatibility equation? Okay, so ang hinahanap natin number of compatibility equations is 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 5. Okay, and then we have, ilan ba to? So 1, 2, 3, 4, 5. So ayan, meron na tayong the total number of compatibility equation, compatibility unknowns or compatibility equation unknowns is na-solve natin. Okay, and then for the step 7, kung maalala nyo, just substitute the values of deflections computed in step 6, ito yung step 6, into the compatibility equations and solve them for the unknown redundance. Okay, so yun lang. So kunin natin yung compatibility equations and then substitute lang. Okay, so delta B plus delta BB RB. So delta B is ito 522.67 plus delta BB, ito yan 32.23 RB plus 28.09 na delta BC times RC. Okay? And then, yung second na compatibility equations, ito yan. Okay? Delta C plus delta CB times RB times delta CC RC. Since our delta CB is just equal to BC, okay, ito lang yan, 28.09 din. And then, so meron na tayong 2 equations. So we have 2 unknowns and then 2 equations. So madali lang yan. So you can use your calculator or the manual method. Okay? So ang na-solve ko dito is that the reaction at B is equal to negative 85.33. So since it is negative, so kailangan ko i-check yung direction ng aking reaction force at B. Since downward kasi yan, therefore i-check ko yan. Yung direction ng aking reaction force is upwards pala. Okay? So reaction at C rin, negative na kuha ko, therefore kailangan ko i-check. Okay, and then for once that the redundance have been determined, the other response characteristics can be solved. So reactions, so meron pa tayong natitirang reaction at A and D. So kasi ang tanong is support reactions. So ang na-solve lang natin is RB and RC. So solving for RA and RD, madali lang naman na yan. You can use the equilibrium equations or by superposition. Okay, any of the methods na you know to compute for the reactions. Okay, so computing, since this is symmetrical lang naman, madali lang yan. So kung mag-summation forces y kayo, considering, so 85.33 times 2, and then since upward yung RC sa RD, so 2 X na lang. Since alam naman natin that this is a symmetrical load from this beam. Okay, so 2x. So alam naman natin equal na lang yan. Okay, and then minus yung load applied. So 2, dalawang 1/2 na 20 na 4. And then minus 20 times 5 must be equal to 0. So, makakuha nyo dyan na x is just the computed reaction at A and D. So, equal lang naman yan. Okay? So, yan na yung ating sagot for this problem. So, this is our reactions for this problem. Okay? RB, RC, and RA and RD. Okay? So, medyo madali lang yung concept niya. Okay? So, ayan lang for this problem. Okay? So, abang-abang lang kayo ng problems to post ko pa. Okay? Yan lang. Bye-bye.